Hello all, in this video we will see how to convert an infix expression to postfix expression, and then we will also see how to evaluate a postfix expression. The postfix expression is also called as reverse Polish notation. So let's see some examples. Look at the first expression, x plus y. This is an infix expression because operator plus is placed in between two operands x and y. X is first operand or operand 1 and y is the second operand, that is operand 2. Now in case of postfix expression, what we do is we first write operand 1, then we write operand 2, and finally we write the operator. Okay, so this is the postfix form for the given infix expression. When you look at the second expression, we see there are two operators, multiplication and addition, and we know that multiplication is having higher priority over addition. So what we are going to do is we are first going to evaluate P into Q. So I'm going to represent P into Q in postfix form. So how I know how to write it, I'll write the first operand, then I'll write the second operand, right, and then I'll write the operator. Right, now this is the result for evaluating P into Q, or you can say the postfix form for P into Q. Then we are going to perform addition. So the first operand for addition happens to be P into Q. The second operand happens to be R. So I have already written the first operand, which is PQ star. Now I'll write the second operand R, and then we write the operator, which is plus. Okay. In the third example, we see that again we have two operators, addition and multiplication is having higher priority over addition. So first we are going to perform evaluation for Q into R, that is we are going to represent Q into R in postfix form. So how we are going to do that? We are going to write Q first operand, we write second operand, and then we write the operator. Now this is the postfix equivalent QR star for Q into R, and then we are going to perform addition. For addition, the first operand is P, so I'll write that. Then the second operand happens to be Q into R, that's the second operand for addition, which I have already written second operand. First I write first operand, then I write the second operand, which I have written, and finally I write the operator. Okay, so this is the postfix equivalent for P plus Q into R. If you look at the fourth example, we will do it the same way. First we are going to perform multiplication. So what we do is we first write operand 1, operand 2, and then operator. Then addition and subtraction are having same priority. Assuming that they associate left to right, first we are going to evaluate addition. So for addition, the first operand is A, so I'll write A, right, and then I'm going to write the second operand, which is already written over here, and then I write the operator plus. Finally I'm going to evaluate subtraction. For subtraction, the first operand happens to be this whole thing, because this part is already represented in postfix form, which I have already written over here now. And then I'll write the second operand, which is D, and finally I write the operator. So this is the postfix form for the given infix expression. Finally we will see this expression. Here we know that bracket overrides all the priorities. So bracket overrides all the defaults. So first I am going to evaluate bracket. When I evaluate bracket, I have C and then I have D as two operands. So what am I going to do? I'm going to write C, D, and the operator plus, right? The next thing is I have multiplication, and I have division. All have same priority. Assuming that they associate left to right, first I will perform this multiplication. For this multiplication, B is the first operand, so I'll write that. The second operand happens to be C plus D, which I have already written over here, and then I write the operator, which is multiplication. Okay, then I'm going to perform this part, as you can see, this whole thing, right, which I can write it like D, E and star, right, D, E and star. Then I'm going to evaluate division. For division, the first operand happens to be this whole thing, which I have written over here already, right? Then I'm going to write the second operand, which is F, and then I'm going to write the operator, which is division. Okay, then I'm left with addition operator. This is the first addition operator, this is the second addition operator. So for the first addition operator, I have this whole thing which I have already written over here. Okay, now let me write this aside, DE star, so that I'll get some space. So DE star, right? Now I'll write the first operand, then I have written this whole thing, and then the addition, and finally we are left with the last addition, which is this one. So that part I'll write it over here. Okay, so this is the postfix form for given infix expression. Now let us see how we can evaluate this expression. It's very simple. What we are going to do is we are going to use a stack, right? When I read an operand, I'll push it onto the stack. So I push 10. Then I read another operand, I'll push it onto the stack. This is my stack. Then when I see plus, I'm going to pop two operands, 5 and 10. 5 and 10. I'm going to perform the addition, which is 50, and then I'll insert that 15 onto the stack. Okay. Then I see 60, I push it onto the stack. Then I see 6, I'll push it onto the stack. When I see an operator, I'll pop two operands. Assuming that all these operators are binary operators, I'm popping two operands. So first I'm going to pop 6, then I'm going to pop 60, right, and then I'm going to perform the division, which happens to be 10, and then I'm going to push 10 onto the stack. Okay, then I see another operator, multiplication. So again I'm going to pop two operands, which is 10 and 15. So 10 is popped out, 15 is popped out. I'm going to perform the multiplication, which happens to be 150, right? So I'm going to push 150 onto the stack. Then I see another operand, so I'll push it onto the stack. Then I see an operator. So what am I going to do? I'm going to pop two operands. So 8 and then 150, and then I'm going to perform the subtraction, which happens to be 143. That part will be pushed onto the stack. So when I evaluate this whole postfix expression, the final result happens to be 143. Okay, I hope you have understood this. Thank you.